Stop. Before you store another secret in your CI/CD pipeline, in your Terraform code, anywhere you're configuring stuff, what if I told you that you can deploy applications to Azure with zero secrets, zero passwords, zero credentials stored anywhere in your code? Not fewer secrets, not fewer passwords, not fewer API keys. I mean, absolute zero. That is what we're talking about in today's video. So today I'm going to show you how GitHub Actions can authenticate to Azure without storing a single secret, and how your applications can connect to databases without passwords, and how this is not just some theoretical dream. This is production ready technology that you can use right now with even so much more comfort. Let's get started. Let's talk about the elephant in the room, traditional deployment. And it looks pretty much like this. You create a service principal, you generate a client secret, store it in GitHub secrets, rotate it every 90 days, 1 year, 2 years, depending on whatever policy you set in your organization, and pray that nobody accidentally commits that into your repository. That sounds familiar, right? Sounds like what you're going through right now, even going through the operational headache of having to renew your secrets every single time and asking who has this password, where do I store it, and all that documentation all mixed up everywhere. That is a problem. And statistically, over 2.7 million secrets were leaked in GitHub in 2023. The average cost of a credential breach, shocking, is about $4.5 million. That is a lot of money wasted. And time to detect compromised credentials is about 197 days. This is not just inconvenient, it's a massive security risk. It's a massive problem in the industry right now. Every secret that you store in your code is a potential leak vector. It's an attack surface, it's a maintenance burden, and of course, it's a compliance nightmare. So how do we solve that? We solve that by going through the better way. And this is the better way. You use what we call OpenID Connect, Managed Identities, and Azure AD, or if you want to call it the new name, Entra ID authentication, so that we can build a deployment pipeline that is, number one, more secure with no secrets to leak, easier to maintain, it means no rotations needed, faster to set up, compliant by default, using what we call the zero trust architecture. I have a to-do application right here running on my computer. It's pretty much nice, it's good and cool. It's a complete to-do app that we will deploy to Azure together right now. I have a blank repository right here that you can clone. Once you get this recording, I'll put a link in the video description and the pinned comments for you to check out if you want to do that. So empty repository, but the code actually is running on my local computer here. You can see it's actually running right here on my local host. You can see all the tests I've done before we started recording this video. And this is the application right here. I can start, I've started recording, so I can check that as done. You can see the progress bar. Of course, it's a simple to do application, right? It's supposed to just work. Of course, there might be some bugs in the app. Don't blame me. You can contribute to make it better. Demo the task application. That is also done. And you can see that if I refresh this page, the data is actually persisted in the database, because in the dev instance, this is using a SQL-like database, so it's portable across repositories. So even if you clone this, you're probably about 40% done anyways. But of course, you can modify that, clear out the database if you so wish to. And what we're going to do right now is to go back into the code itself and explore how this really looks. So first thing we're going to do is look at the architecture. I'm going to stop running this right now because I've demoed it, right? So this is the architecture of the application. We will have GitHub Actions that will build our application, build our infrastructure, and deploy our applications to that infrastructure. I will do no manual step in this code. The only manual step I'm doing right here is committing my code to the repository, and every other thing is handled automatically. All right, so we've demoed our to-do application, and the way it works is we have an Azure App Service. Of course, can use any other workload, function app, AKS, Azure Container Apps, you decide. But to make things simple, I'm deciding to use Azure App Service, and this is connecting to an Azure SQL database. In your case, might be PostgreSQL, might be any other kind of SQL database, or even Cosmos DB. You decide. And this app service is connecting to the database with no secrets. The connection string is using a managed identity, so it's actually saying, hey, here I am, use me to connect to this database, and authentication is done between both of them. So that is how they're gonna connect. So The authentication flow is pretty simple. First is that GitHub Actions for the deployment here. GitHub Actions we use instead of using client secrets, we use OpenID Connect, or otherwise called OIDC, to prove its identity to Azure. Think of it like you're showing your driver's license instead of giving someone the keys to your car, right? That is how the GitHub Actions will automate or authenticate with Azure. And when this workflow runs, GitHub generates a token that says this is really the main branch or whatever branch you configure for it to use to connect to Azure. And what happens is that Azure will then validate that token against Entra ID or Azure AD and grant temporary access to that client, to that OIDC client. And for App Service, what happens is that the application itself, which you've deployed, will assign a managed identity to the App Service. So it's like giving the application a passport, and it's verified identity in Azure that does not require any password. So that identity is what is then used to authenticate with the Azure SQL Database with no connection string, passwords, complexity, just identity-based authentication. Same with Key Vault, app setting secrets, every other thing is automated that way. So let's see how this works. There are a bit of things we need to modify right here in our code before things start working out, because I cloned this from my prep repository. So let's set a little bit of things up. So this script right here, what it will do for us is that it will go ahead and take our repository inside of GitHub with our organization details. So I need to modify this one right here. So the organization here is code cloud DevOps. So in your case, when you're cloning this, you will have to modify this to the repository you have actually cloned this to your GitHub username, and then the repo name, whatever name you give me your repository, and then the app name itself, and set the GitHub variables. Every other thing right here is already connected to my Azure account. So if I go to my terminal, you will see right here that I am authenticated to my Azure personal account. So what I need to do is go into the folder that contains this script and just run it, right? So I have Code Cloud DevOps, which is this repository that we have inside of GitHub, this one right here, Code Cloud DevOps. Okay, and then we have our zero secret application deployment to Azure. You can give it any name, but the name must just match the repository you have set inside of your GitHub account. Just confirming, that's why I had to paste that over again. And then every other parameter, you can give it any name you want. If there's any error, this skips. So let me close up the terminal just here so we can go through the script a little bit more and zoom in a little bit into that. So what the script does, gets my Azure tenant ID and then checks for any existing app registration that I might have configured. If so, it reuses it. If not, it creates a new one. And then the next step is that it sets up the federated client for an app registration inside of Azure to connect to this GitHub repository using all these credentials. And then also on my computer, I've installed GitHub CLI, I've installed GitHub Actions, I've installed Azure CLI on my computer. So those are prerequisites of things you need to have installed. Just noting them again. You are just noting things you need before we actually get started deploying. You need to have the GitHub CLI installed. You need to have Azure CLI installed, and you need .NET, of course, if you're using the .NET example for the purpose of this. And of course, you need an Azure account, a free Azure account. If you go to azure.com/free, you will have an account to actually go with. So that is just the basic things you need to get started with that one. So this ensures that the app registration or service principal in this case exists. And then what it does next is to assign the contributor role to the subscription we'll be deploying the application so that it can deploy stuff there. And then grab the credentials, which is the client ID, tenant ID, and subscription ID, because that is what will then be used to set up the GitHub variables. So what we're doing here is we're grabbing all these details right here and then calling another script. Okay, calling another script to set the variables in there. And after that is done, what we'll then do is that we'll grant directory reader access. What is directory reader access does, which is this script right here, directory reader access, is let the app registration we've created be able to read the tenant details, the Entra ID, so it can assign identities here and there, even grant privileged role admins only for the registrations, only for the identities of the applications that we need, because we are passing simply parameters here. You can go through the script later on. I don't want to waste your time going through scripts that can already explain themselves. So I'm just going to run the setup GitHub OIDC task right now. I will close this one and go here. So I'm going to go run setup GitHub OIDC. So what I need to do now is set the subscription ID, which I need to grab from the Azure portal. So if I go into my Azure portal, and this is the only manual step we need to run in the case of this accounting. So I'm going to use this Azure subscription right here. Don't worry, you can see my Azure subscription. You can't have access to it because you're not authenticated to me. So yeah. So copy this, paste that in here. It's pretty much running its stuff. So it's checking if an app registration exists already right now. It does not exist, so it's creating a new one. And it set up the federated client right about now. So quick, so fast, no manual steps. Service principal also created. Next step is to now grant that service principal, directory reader role, and every other admin role that is needed based on the script that we've had in the repository. Which I think is quite fun, right? Because all these steps are just boom, cool. And these variables have been passed inside our GitHub repository. Let me show you that auto magic happening. So if I go to settings right here in my GitHub, and I go to secrets and variables, and I go to actions, and I go into variables, and all right. So let's check our Azure environment actually. Let's get the app we're using, this one right here. So if I log into Azure and I go into Entra, and I go to my app registrations on this side, in Google, in AWS, it's probably called another thing. So let's paste that in. So this is the one created today, as you can see. And if you go over into the secrets area, let me just make this a little bit bigger, and then we see this is what we need. This is the federated client that was just configured for us automatically. I like using that word automatically. As the code is building, I'll go through the code and explain what it does so we don't waste so much time going through stuff. So I'll commit all this to the repository now. While that is trying to get itself really nice, let me walk through this again. We've gone through the application, that is cool. Infrastructure here. So we're using Azure App Service and a SQL Server module to be able to deploy the application to Azure. It's quite direct, it's quite nice, everything is rosy. But then we now set up Managed Identities to be able to make Azure workloads authenticate with each other. We have role assignments inside of the Terraform code to make things work. So these are all the credentials we needed to set. Don't worry, this code is fake here. Just passing your credentials here and things work. All that is documented inside of the README file once you clone that up. And the backend setup, it creates a Terraform storage account for the Terraform backend if it does not exist already. If it exists, it reuses what you currently have. If not, create a new one. And then use the application and then deploys it. And then this is zero secret design. So you have a GitHub Actions OIDC provider to authenticate with Azure, and then Microsoft Entra takes care of all the identity, authentication, and token validation and all that. And then your application does sort of the same process. to ensure that authentication is secret or private and secure between all the workloads in Azure. No secret is stored anywhere, and this is how the data flows in the application. You have your user making an HTTP request to the to-do controller. Your data communicates via ORM, EFCO in this case, to your Azure SQL database using managed identities. And if you need it, you use Key Vault Secret and Azure Application Insights to be able to get application telemetry. And then deployment flow is pretty simple also. I just need to make this a little bit bigger so you can see. Oops, I sort of entered edit mode right there. And then this is the entity diagrams and relationships, and some of the environment variables that will be configured for the application, and some cost optimizations you can do right here, just documented right for you. So let's look a little bit at the Terraform configuration. So if I go to, let's close the source node here. If I go to the modules, so for the modules here, we have the App Service module, we have the Key Vaults module, we have the Managed Identities, Monitoring, which has App Insights, we have the Role Assignments module, and the SQL Server module. Those are the Terraform modules we're using for the case of the. Let me just expand the App Service module as an example here. So we set the Azure RM App Service Plan, Linux Web App, and then the identity type we're using, because we're using sort of one identity to do every other thing. So the identity is configured right here. So set up a user assigned managed identity, then we use that identity across all the apps. Technically, yes, you can use various identities for the various cloud workloads, but it sort of makes life a little bit harder, because there's also limits to role assignments inside of Azure itself. So you want to have full control of that, especially when you're in production environments. So that is that. And then for the workload itself, is just we have the main Terraform file that calls all the modules. So first we set up the resource group, and then we set up managed identities, then Key Vault, SQL Server, App Service, Monitoring, Role Assignments, all that stuff right there. You see here, there are no hard-coded values, right? And then we have some outputs right here for us to make use of. And then we have your Terraform.tf file. You could commit that. So we ensure that we made this name unique. But of course, when you get to real production environments, these values would vary for you based on your organization naming conventions and all that. So, but of course, I'm almost certain these values should be sort of universally unique by the time I deploy, especially for values that are needed, workloads that need unique names inside of Azure. So let me commit this now. And we are in the main branch now. So let's publish this branch. Now this branch is published now. So let's get into Azure. No, GitHub, sorry. Go to the Actions tab right here. And we should see our action just populated. Oh, actions. I didn't talk about that, right? That is great. Let's get to it. So while this builds out, let's walk through the actions file. So the actions is actually the magic here. It's what the glue that holds everything together. So first is, so we have a readme file, of course, that defines all the workflows that we've configured. You can go through the documentation in details for that one. I don't want to bore you through all the boring details that you can read up and all that, but I just wanted to show you that this works and sort of walk you through the quirks or some gotchas you might encounter as you run this in your application, because I've encountered that even while prepping for this. So Terraform plan here, I'll go from bottom up. Terraform plan here, what it does is that it does a, just like the name implies, it plans the infrastructure deployment. So it shows you what is supposed to happen when the application is deployed. So that does that bit using Azure Client ID. Terraform backend setup, simple as that. What it does is configures the Terraform backend configuration, and Terraform apply deploys the infrastructure itself. And we have the .NET build that builds the application to be ready to deploy and ensures that it's in a publishable state for Azure. And that is all this bit does for us. So, and the reason I did this was that I broke this down to ensure that everything is modular. So if one part fails, I just modify one file and not like 100, 150 lines of code, because that is boring. And it's one of the best practices also of deploying apps in this age and time. modularization. Do not repeat yourself. And of course, there's the bit that deploys the to-do app after all the infrastructure has been configured. So you see here, it uses the workflow for .NET build, uses the Terraform backend step, then does the Terraform plan and deploys the infrastructure. I didn't put any manual approval in this flow because this is just a demo. Normally, you're supposed to put sort of a manual approval if your workflow and your organization needs it. Of course, if it doesn't need it, you can skip it. And then do it full Terraform plan, apply the full Terraform plan. And why did I do this flow? So in some cases, when you deploy infrastructure, it's a case of a chicken and egg, right? So when you deploy the infrastructure, some things need to take a bit of time before they are fully provisioned. So you deploy parts, wait a bit of time before they're ready, plan again to get the outputs from that little bit of step before you continue running. So that is the flow I've worked with here, such that you can deploy end to end without breaking stuff. That is the flow here. So we deploy the app service, also configure Azure SQL, especially this one, the Azure SQL bit. I'm going to confess to you right here, it showed me pepper. But finally I overcame and I'm able to show you this demo today. So that is the bit here. So this ensures that Azure services can access this SQL so it can run the first bit of running, and after that it removes the firewall configuration. What else? Oh, I also have templates, of course. Oh, templates here don't actually work anymore. I wanted to templateify this, but I'm gonna figure that out. In case you find a way to make it work, make a pull request to the repository. I'm very happy to review that and merge it in and update documentations if needed. Maybe we'll record another video on this one. Let me know in the comment section if you find that helpful. Also, so that is the bit of what we've done right here. But of course, everything I've modified in this code, I'm gonna dumbify it so that you don't have to worry about it. So there's a little bit of a problem here now. So for the build.NET application that succeeded, Terraform backend succeeded. It failed on Terraform planning. So what happened with Terraform plan? So Terraform initialization. The request was arrived because authorization permission. So fine. So it says it failed to get existing workspace because the request is not authorized to perform this operation. So this is a permission error. So this service principal that has been used is not being led through to work with the Azure Terraform backend. So we have a fix for that. So we have go to our script here. So grant storage access is what we need. So this one right here, grant storage access. So what it does is that it grabs storage blob data contributor to the service principal that we are using. So let us fix that now. So I'm just going to use this one. So I'm going to say grant storage access. You probably ask me, Dara, why do you have all this figure out? Because, hey, if things don't work automatically, you are also supposed to be able to figure out the quick manual fixes. That is what I'm doing right here. So the code is grant storage access, right? And then I just want to pass in the parameters right here straight up. Service principal object ID here. I'm just going to log into Azure together. Yes, it was in our terminal previously, but I sort of closed that bit. So client ID. Actually, what I need is the object ID, not the client ID. Object ID. And then the storage account name. I had it in my terraform.ts vars file. I'm just gonna put this to the side here. Is it there or where? Backend. Variables. I saw it just a couple of minutes ago, right? I can grab this literally here from Azure because I know exactly what it is. So DO Central SA is the name. So resource group is this. Resource group name is this. I'm just gonna put those in quotes, single quotes here, just to ensure that it doesn't mess up with any other thing. And I'm just doing that to be safe, right? It doesn't, I don't think it necessarily needs it, but just to be on the safe side, I do this kind of things when I'm doing my deployments. Resource group name set, and then we set the storage account name. Storage account name is this. All right, let's see. That didn't quite work out. It says it granted it. So let's run that GitHub action again. It says it granted it, but let's see. So let's retry this step. Let's see what happens. If it really granted it. That was a warning, but it didn't show up as an error. Failed again. So let's manually do this, right? Okay, so let's go into Azure and fix this sort of manually. So I'm gonna go to access control, and then I will add a role assignment. Maximize this. Blob data contributor. Yeah, that's the one I want. And I want to assign that to. Oh, I didn't pick the member of that. So I want to assign this to GitHub. Cloud secret to do is what I want. Not cloud code, because that's another project entirely. Assign that role. Cool. That is done now. Let's rerun all jobs just to be safe, because it needs to do the Azure login and grab the token again. So let's run that. Now, this kind of things happen, right? When you're deploying, things that are supposed to work just stopped working. And once the manual steps are done, every other thing ideally should succeed. And of course, we can always debug things together to ensure things work. And the reason I'm not sort of doing it all works, deploy off camera I did is, this is real life, right? These are problems you might face as you're deploying apps from day to day. I want to show you how I would approach solving them. Yes, I could have used AI to fix this problem. So I put it in Cloud Code or GitHub Copilot and asked it to solve it for me. But I did not go through that because I wanted to show you that my thinking process generally around solving problems. Yes, AI will make you do it faster, but if you still don't understand the basics of things, it's really not good, right? It's really not good for you. If you're going for an interview, AI is not going to do the interview for you. So you still be the one to sort of pass that exam, pass that interview for yourself. Let's get workspaces. This is in the SQL role assignment module. All right, let's do this now, right? Grant privileged role admin. tenant privileged role admin. What does that tell us to do? The service principal object ID, which is, I had it in the clipboard earlier on also, but let me skip that and go back into Entra and grab it. I'm gonna need this pretty soon. App registration here. I'll look for GitHub. Object ID. And then the tenant ID. This is the Entra tenant ID. What account am I even using? Let's try the client ID instead of the object ID. Looks like the object ID didn't didn't work. Let's run this with debug enabled. Right, so we can actually see the raw output of this. Azure login was fine. There's a Terraform initialization that was failing. So maybe some things I was supposed to modify that I did not. I forgot to modify. So let's check that out. Terraform backend was good. Init was failing. Wait, what? It actually passed now. For some very interesting reason, it actually passed now without changing anything. So it's doing a Terraform plan now. So these are all the things it's going to do for us. It will create our app service plans, create our app service, create our resource groups. Then it is going ahead now to deploy the base infrastructure, which is good. That's where we want to be at. That is cool. So looks like the scripts we ran actually worked. Maybe I should have just put the debug steps in, but that was not needed actually. I just need to wait a while. I think the reason for that is when you apply rules, it might take a couple of minutes before the rules actually propagate across the Azure estate, which is kind of understandable. All right. So remember, this is the goal. One, our to-do app with a .azurewebsite.net URL, not a localhost URL. So that is deploying now. So let's see how that goes. Going on to try to deploy the complete infra now. Let's hope there are no failures here. Note here, I've not configured any. All I've been passing across this pipeline during all this deployment has been variables, no secrets whatsoever. Even if the variables get compromised, I'm not scared. Why? Simply because they are variables. Okay? And authenticated access is actually needed to make these variables work. And our full infra deployment is in full swing. So this will now deploy the app service set the managed identity connections, and hopefully things should be fine right after. So this is now setting up the app registration, app managed identity with the SQL database, and then deploying the application. Now this is the complete flow. There should be no more manual steps needed for this now. Remember, no secrets, nothing whatsoever that is compromisingly bad in our code right here. All right, so now the deployment is completed again and the app is successfully launched, which is kind of a good thing. I'm just going to do another refresh on that to be sure it's still working fine, and that is good. So I'm going to say hello world and add that to our to-dos list. So what I want to verify is that this should not have an issue anymore now. Cool. And if we go to the log stream, we should hopefully see something working out fine right about now. Let's go to the last 5 minutes of the log stream. So sometimes just rerunning stuff makes things, fix things. So it kind of works now. I am doing this again. That's now. I could check this is completed. Logic works. Check this is completed. Logic works. Perfect. So what we've done now is that we've successfully gone into GitHub to redo our deployment. Everything works fine now. We've literally had no secrets whatsoever in our source code. Yes, I know it took a little bit of time to actually get through the debugging, fixing, and everything out of this one. But the key here is when you deploy apps, sometimes it doesn't work quite as planned, and sometimes it just works straight out of the box. But we've gone through the debugging steps, found how to fix stuff, and also literally fixed it, and everything works fine. The key here is you are able to put best practices to use to be able to have enterprise ready or secure practice deployment in your day-to-day project. So if I go here now, so what we've done now is we have this pipeline that runs end to end now without needing any further manual intervention, except of course when there are bugs and maybe bad queries in our code and things just don't work out fine. So what I could do now is I could go ahead and modify a little bit of our code. So if I was to go ahead and say, oh, I come into the code, let's pick something in our C# code, for example. Let's go to the source code area here and go to do app and go to views and go to let's go to index, for example. So let's change to 0 secrets to do app, right? Change this so and commit that to our repository. So what will happen now is that this bit of code will then change to just show that things work. We'll just modify our code now and everything should work fine. So you see right here, you have more than to do. After the deployment is completed, we don't need to do any extra manual steps. So we can now focus on actually writing code, making the code better. If we need more infrastructure, write infrastructure code. Terraform configuration is already there to handle the deployment. Grant permissions, scripts are there that we can manually run if the automated steps don't work. And these scripts are only run manually one time. The rest of the step is automated from here on then, and everything just works seamlessly. So that is it. We've been able to deploy zero secrets applications to Azure using GitHub Actions, OIDC, Managed Identities, and various Azure workflows. I use Azure App Services here because it's the most straightforward and cost-effective one to use. Yes, we could use Azure Functions, we could use Azure Container Apps, Azure Container Instances, virtual machines, AKS, you name it. You can even deploy to maybe even other clouds. But the purpose here is so you can see the practice and play and then apply it in any other project you might want to do in the future. It might not be a to-do app you're writing. It might actually be a full-blown solution you're writing. The principles still apply here. So that is it, guys. If you have further questions, you can reach out to me, put a question in the comment section, ask further questions. If you want to see more demos like this is what I want to show further going forward on the channel. If you want to see more demos like this, put in the comment section. All the source code that I've used for this demo are in the video description and also the pinned comment, so you can check out, clone for yourself all the instructions you need to go through, each of the steps, and each of the minor steps you actually need to go through is also documented there, so you can actually practice this over and over and over again. And of course, if you have any further questions, you know what to do. Drop them in the comment section and I'll get to them. I'll see you again in another video. Happy secure deployments.